Okay, question number 1, you've got half base times height. Neither of those expressions for base or height is easy to halve, so just do base times height and then halve the whole lot, and you're told that that's equal to 10. So therefore x plus 2 times x plus 3 equals 20. And now let's kick in the cases strategy. We're told that x is a whole number, and x can obviously only be positive because it's a length or part of a length. So what could x be? It could really only be one of these. We've got time to go through them. If x equals 1, we have 1 plus 2, which is 3, times 4, that's not equal to 20, so reject that case. X equals 2. You have 4 times 5, which is equal to 20, so we're done. X equals 2, simple as that. Next one, you've got the base is x minus 1, the height is x plus 3, neither of them is easy to halve, so when you work out the area, just multiply them together and halve the whole lot. We're told that the area of that is 65. The word is often becomes equal signs, double both sides, gets rid of the fraction, so you get 130. Now, just thinking that I made a mistake reading this. It's not 65, it's 70, sorry. So it's 140. Now we're getting a bigger answer here, so I'm going to start bigger. X equals 5, you get 4 times 8, that's not 140. Let's go way bigger, x equals 9, you get 8 times 12, that's not 140. Let's go bigger, x equals 11, you get 10 times 14, which is 140. So therefore that's the answer, x equals 11, just by elimination. Question number 3. Okay, so the area of a kite is half the product of the diagonals. Again, it doesn't matter what you halve, and in this case, since neither is easy to halve, I'm just going to halve the whole thing. We're told that that's 45, so x times x plus 1 equals 90. So therefore, well, what could x be? This is a nice big one, so let's start with x equals 5. Is 5 times 5 plus 1 equal to 90? No. What about x equals 10? 10 times 10 plus 1, is that equal to 90? No, it's too big. That's 10 times 11, so let's go x equals 9. Is 9 times 9 plus 1 equal to 90? Yes, it is, so that's your answer. So that's question number 3. Question number 4. The area of a trapezium is half the product of the sum of the parallel sides plus the gap between the parallel sides. Now, these are my parallel sides. You add them up, you get x plus 7, and here's the gap, x plus 1. Neither of them is easy to halve, so just write a product. Halve the whole thing, and you get 8. So x plus 1 times x plus 7 is equal to 16. Let's try x equals 1. What do you get? You get 2 times 1 plus 7, which is 16. So we did it on the very first try, x equals 1. Okay, normally there would be a possibility of other solutions, but because we're told x is a whole number and x is can't be negative, we can narrow it down very quickly using the cases strategy. Area of a triangle, we're told that the answer is 9 pi. Remember, the word is becomes equals. Here's the formula for the area of a circle. Divide both sides by pi. So let's try it with x equals 3. You get 3 plus 1 all squared equals 9. That's not true. Try x equals 4. 4 plus 1 all squared is 25. That doesn't work, it needs to be 9. What about x equals 2? 2 plus 1 all squared equals 9, so that's good, so that's your answer, x equals 2. Question number 6. Half base times height. Well, this times the base is easy to halve, it's just x. So half the base times height. We're told that that is equal to 40. So this is 40. Now try x equals 1. 1 times 1 plus 3, that doesn't equal 40, so that's no. X equals 2. 2 times 2 plus 3 equals 40, no. Let's go a bit higher. X equals 4. 4 times 4 plus 3, that's 4 times 7, which is 28, so that's no. Let's try x equals 5. 5 times 5 plus 3, that is 40, so there we go, that's the answer, it's x equals 5. Question number 7 is another kite. So half the product of the diagonals is the product of the diagonals, all halved, is equal to 75, so x times x plus 5 equals 150. How could I get 150? Let's try big. 9 times 9 plus 5 is 9 times 14, that's not 150. So reject that. What about x equals 10? 10 times 10 plus 5, that is 10 times 15, which is 150. So that's our answer, x must be 10. Number 8. Now this is a parallelogram. Now, a parallelogram is an example of a trapezium. So, you want the product of the gap between, which is x minus 3, and and the sum of the two parallel sides, and you need to halve something. Well, if you add x plus 2 to itself, you'll double it, you halve it again, you'll get back to x plus 2. So, that's what we need. We're told that that's equal to 4. Now, sorry, that's a mistake. Sorry, I should have said that was equal to 6. Okay, I'll just say it again. This is one of the halving formulas. You go this times half of this plus this, or you go half of this plus this times this, or you just go this plus this times this and then halve something. But since that plus that is just double that, when you halve it you get back to that again. So in other words, this is half of that plus that. So therefore this is the area of the trapezium, it's a halving formula, that is half of what this plus this is, and that's just been left alone. So anyway, now just try x equals 1. That's ridiculous because then you get a negative there. Let's try x equals 2. Still get a negative. X equals 3 gets a 0. So let's try x equals 4. You get 4 minus 3 times 4 plus 2, which is 6. So that's great. So therefore that's your answer, x equals 4. And finally number 9. I don't need a halving formula for this. This is just x plus 3 times x plus 3, the area of a square is 25. What could work there? 1? No, that would lead to 4 times 4, which isn't 25. What about 2? That will lead to 5 times 5, which is 25. So that's done. The answer is 2.